Hello and welcome to the Ecomodernist Channel Live. We're privileged to bring to you a technical expert who works with deep isolation, a company dedicated to giving us another very useful tool in addressing the so-called waste problem. Bret has an MS in nuclear engineering. In the past, he's consulted for the Clean Air Task Force and helped run many nuclear plants in the American Midwest. Welcome to the show, Bret.
My pleasure. Thanks for having me. It's a pleasure to be here. What we have existing in the United States is a really safe interim sort of storage system that is driven by, pardon my French, badass colleagues of mine and yours in the nuclear industry. And there's always going to be something that needs isolation. And right now, the prevailing science from experts I trust, experts that spent their entire careers working on this topic, and we've researched and looked at the storage of nuclear waste and spent nuclear fuel for decades at this point, 6+ decades. Those experts have all agreed and done studies and looked at and seen that deep geologic repositories are a cheap and effective way to isolate this material. I'm an advocate for this other stuff, right? I like recycling. I like these other things, but it doesn't eliminate all your need for doing this, okay? And if you know and you've looked at the cost scales of deep geologic repositories, the thing is just that other stuff is so much more expensive. Forever dry cask storage or long-term dry cask storage without a plan. The Dutch planned for, have a facility that they planned for 100 years of dry cask storage because they planned it that way from the beginning. I'm not talking about that. I'm talking about when you try to backfit a short-term storage solution. In the long term, you have more costs, you have more difficulties, and you increase your hazards versus looking at more options or having a larger set and pursuing multiple options at the same time.
If you put this waste into a deep repository, could it be easily removed and then recycled?
So that's the concept of retrievability. And retrievability is a great thing in concept, but again, as you start talking about retrievability, you increase the cost of things. And in some cases, that can be a significant cost. In some cases, it can be low. I've also seen studies for Yucca Mountain looking at long-term retrievability and seen the costs, and it's been astronomical because they didn't plan for that long of retrievability. They planned for some amount of retrievability. And I apologize, I'm not a Yucca Mountain expert, so I can't say how much it is. I believe it's on the order of decades. I didn't need to learn a lot about Yucca because I knew it was never going to happen, unfortunately. Even though it's a great solution for what we were looking at, but a partial solution, even at that, because Yucca was for 77,000 tons of waste, and we currently have 85,000 tons or something. So retrievability has its options and its opportunities, but from a price and a cost standpoint, you're probably looking at decades to 100 years, 150 years as being like what's feasible for us planning for retrievability and then paying for it as well. And when you start talking about timescales like that, if you're really focused on nuclear energy and nuclear technology and all that and everything, I would really hope that in 50 years, our cheapest option is not being sullen and upset that we sealed up this chamber, or 100 years as a better example. On year 101, that we're not upset because we sealed it up, because we're like, oh no, we got to dig up this from this 100-year-old plan, which was probably a 140-year-old plan because it takes a long time to site and fill the facility. So you were probably closing chambers on a rolling basis, all this stuff that you can do. I really, really have a lot of a different belief in science and technology that it'll probably in the future have whole different practicalities. Because 100 years ago, look at what airplanes were. Right. Or look, like 100 years is a long time.
So just to review some of the stuff that I've covered recently, yeah, you're right, is that retrievability is fundamentally in conflict with many of the goals of isolation. It is the concept that, well, okay, you have to be sure that there is limited to no access to the facilities. You got to be secure. You've got to make sure that no inundation can take out multiple rooms. And so what Jim Conca says, yeah, it's like a screen door on a submarine. It doesn't make any sense. And Jim's a really big critic of Yucca Mountain, despite working on it. He was told, you're not a policymaker, you're a scientist. Don't give us your policy ideas.
I was just going to say, screen doors on submarines are really dumb ideas, but they have lockout chambers for seals and do all sorts of crazy stuff nowadays. I really believe that a lot of my colleagues and the people I went to school with are some of the smartest people I've ever met anywhere in the world, and most open-minded. But nuclear engineering is hard. I really, really have a lot of a different belief in science and technology that it'll probably in the future have whole different practicalities. Because 100 years ago, look at what airplanes were. Right. Or look, like 100 years is a long time to think of. So yeah, I get that. And I get the challenges of what we're all talking about. Retrievability is at odds of that. But, nuclear engineers and nuclear professionals are up to the challenge. They've done harder things before, in my opinion.
Why is that even necessary to have this long-term isolation?
Okay, so these things are licensed by the NRC for 40 years with the potential for 20-year renewal. And a 20-year renewal isn't like, hey, walk in and just get your paperwork stamped. There's work you have to do. And it's probably not inexpensive. I don't know. I'm not a cask renewal expert, but all I'm saying is they're probably doing that right now to get 20 years more time. These things are required to be inspected and looked at. They're air-cooled. Many times they're near bodies of water, which have salt and stuff like that. So you're having penetrations where the air is coming in and all this stuff and everything. I don't know a lot of things in my life, in my experience, and I'm an engineer, that we design to be like exposed to elements and plan for it to last for 60 years and then say, nah, but let's let it last 100. I mean, like, that doesn't sound great to me. Now, so what you have to do then at that point is start opening them up and doing something with them. And if I'm correct about the timelines, we're going to have to start opening these things up in 2044 in the United States for a license that goes all the way through its 60-year and a renewal. And what is that? Is the fuel going to be damaged inside? How do you open them up? With what procedures? Where do you move them to? Do you need a hot zone? I don't know the answers to these questions, and not a lot of people do, if any people, because we're not planning for it, because it's not their responsibility, and they didn't plan for the government to shirk this responsibility through 2044.
This is the San Onofre, which is not going to be an active energy generation site. They are not going to have the responsibility. This is like illustrative of the two different policy issues that you're sort of talking about, is that San Onofre will not have radiological staff other than what is essential. They will not have beyond what they need to monitor and watch these dry casks. Whereas in Columbia Generating Station, we are going to continue to generate power for many decades into the future. And so we will have additional staff available. So just to review some of the stuff that I've covered recently, yeah, you're right, is that retrievability is fundamentally in conflict with many of the goals of isolation. It is the concept that, well, okay, you have to be sure that there is limited to no access to the facilities. You got to be secure. You've got to make sure that no inundation can take out multiple rooms. And so what Jim Conca says, yeah, it's like a screen door on a submarine. It doesn't make any sense. And Jim's a really big critic of Yucca Mountain, despite working on it. He was told, you're not a policymaker, you're a scientist. Don't give us your policy ideas.
I was just going to say, screen doors on submarines are really dumb ideas, but they have lockout chambers for seals and do all sorts of crazy stuff nowadays. I'm a nuclear engineer. That's what my degree's in. I'm not that smart. I cheated a lot in college, all that sort of stuff. I really believe that a lot of my colleagues and the people I went to school with are some of the smartest people I've ever met anywhere in the world, and, most open-minded and all that stuff and everything. But nuclear engineering is hard. I really, really have a lot of a different belief in science and technology that it'll probably in the future have whole different practicalities. Because 100 years ago, look at what airplanes were. Right. Or look, 100 years is a long time to think about. There's a reason for, that's because of hazards and difficulties and physics and all that stuff and everything. So yeah, I get that. And I get the challenges of what we're all talking about. Retrievability is at odds of that. But, nuclear engineers and nuclear professionals are up to the challenge. They've done harder things before, in my opinion. Nuclear engineers are great at what we do. And if we wanted to come up with solutions for just opening the cask, we'll build a bigger facility.
This is Hanford Reach. This has so much room.
This is the X-Energy site, I believe, as well.
Yep.
It's not that they don't have the room, and it's not that we don't have the capabilities and the technical know-how, but the question is, what is the practicalities of this?
Right.
How long are we going to do this? And then if we just want to keep them in dry casks, then we should be designing 100 or 200 year dry casks right now, but those are going to be even more expensive. And can we open the nuclear waste fund then to do that? These questions make me want to drill a hole in my head to relieve the pressure. So the challenges here are not just like technical or feasible when you look at the way we do it right now, because the way we do it right now is, again, I said, engineers were great at engineered safeguards. We've become amazing at it. The safety record of this material stored the way it is great. But this material is dangerous. And every time you pop them open or you have to do something to it, you're exposing people to danger. Those are hazards. I value workers' lives just as much as I value public lives and everything like that, because I don't think there'd be public exposures and everything and whatnot from any of this stuff. But I don't want workers to get dosed either unnecessarily, because right. And even from my horrible capitalist pig perspective as well, because I am a horrible capitalist pig, I don't want the costs. I want nuclear costs to drive down, not drive up. And doing unplanned things like storing waste on site for longer than we ever planned to do that just drives nuclear costs up. And I'll just say is something that is a principle of the original anti sort of nuclear platforms that were started in this country. Stall progress on nuclear disposal, stop everything so that Congress and the operators give up. That's quote unquote, so.
I've seen amazing videos on robotics.
Robots are great, really cool. It's a bitch for, pardon my French, it's a bitch for electronics or any of that stuff or robotics? High intensity radiation fields. It really just depends on how much money, again, you want to spend. There's ways that you can build, but that becomes more and more costly and less practical. So again, you can do all of these things. We can protect people. We can do all this stuff. It's just costly and less practical.
I don't know if you've ever seen this video that was done, excellent video, that was done by Kirk Sorensen, titled, Is Nuclear Waste Really Waste? And the whole thesis of what he was saying is that once you open up a dry casket after a long number of years, and 15 years minimum, actually, there's a smorgasbord of precious metals and all kinds of materials in there, including platinum, palladium, rhodium, and I can't even remember everything, but other precious metals too. It was like an amazing amount of stuff.
I know where you're going.
Yeah.
And you're like, why can't we keep using all that crap? Right? Why can't we pull it out? Why can't we use it in thorium MSRs? Why can't we use it in all this? One of the stories that I love, we're talking about commercial waste right now, okay, right? One of the things that people have always said, all my schooling, all my education, all my experience in nuclear engineering, defense waste is disgusting. It's even worse than commercial waste. They're like, there's no value in defense waste. That's what I was taught in my schooling. There was an individual at Oak Ridge that for I think it was a decade and a half, tried to convince the government and the DOD through proper channels that there is good stuff in that waste. A cancer-treating isotope of americium, I believe, in that stuff, and I want to pull it out. He spent 15 years, I think, trying to get approval. When they did the testing, they figured out that this isotope was 90% effective at treating 80% of non-Hodgkin's lymphomas, or reverse. But that still left all the other crap, and it was still super expensive to pull all this stuff out. And they still couldn't get all the americium out of the material because at a certain point, the value stream declines and the practicalities decline. So I agree with you. And this is where I think Carl was leading, talking about options. He was just showing previously a picture of a repository. He was showing, decay pathways and plots about, what happens to the nuclear waste over time and spent nuclear fuel over time. But you don't have to just use MSRs because, like I said, Oklo wants to be recycling fuel, and that's what their project with ARPA-E and the DOE is about right now, I believe. They have a metallic fuel in their sodium-cooled reactor. Opportunities can help change your dynamics of your long-term or isolation. So maybe you don't have to build a facility to protect for 100,000 years. You have to do it for 10,000 years. Okay. And these people are like, Bret, these timescales are ridiculous. Gabe, you had something up that showed ridiculous timescales just before, right?
Oh, I've got it. This is from whataboutthewaste.com, Nick's extension of What is Nuclear. So the reality is that you can reduce it with partitioning. You can reduce the time scale for the quote unquote danger line. That's that reference, the heavy reference dotted line this is the danger of uranium ore, basically. And so that's where we get this 130,000 years for our total decay in spent fuel. And then when it's partitioned, the bad parts, they're 300 to 1,500 years.
Show me you can pull it all out and you can do it, and it doesn't cost you an arm and a leg, and freaking do it. And let's reduce our burden. But what do you do with stuff for 270 years? Doing my math, that's like longer than the history of the United States. So looking at these timescales are significant, even if you did extreme and expensive challenges, or we sit around and wait for 50 years and get cheaper technologies and everything like that. And this is like the state of Illinois resolving its nuclear waste program alone, but that's what they did here. And they completed a nuclear waste repository. I think it's going to be online next year, if it's not already accepting waste right now. And it shows that this is something that can be done with community consent. The community is super embraces this project. And looking towards the future, we should be considering our options for recycling and building advanced reactors that use recycled fuel and everything. But that does not mean that we're not going to need a longer term isolation solution. And now, final disclaimer, final plug, I work also and consult for Deep Isolation, a deep borehole company, which also offers another sort of approach and option towards deep waste storage. Drill a deep borehole and go horizontal and store the waste and everything. But this, again, is not going to be forever retrievable. This is not going to be something that is as cheap if we did it for all the waste in the United States as if we did consolidated storage more in a deep repository or with other deep geological options. So boreholes complement deep geologic repositories, complement recycling, complement advanced reactors. This is just like the energy story. We need an all of the above approach, and one thing does not eliminate the other. It just reduces the challenges and the burdens associated.
There's a great amount of drama about how, oh, we don't really need any isolation. We don't need any long-term storage. Well, this is one slice at the policy pie, is to advocate for reforming our understanding of these systems. Why do we need a permanent solution now when we don't know if we're going to make it through climate change? This is like the cutting back at the perfect is becoming the enemy of good. And surface level storage, while it may be expensive long term, if we're trying to build out more nuclear plants and we see nuclear breeders on the horizon, maybe it's not terrible. But as you said, even with partitioning, even with the end product of those reactors, we got to put it somewhere. And some people are really nervous about leaving it. The motivation behind something like this is if we take all of our surface level vulnerable things and we think we're going to war, put them way underground.
Hey, we could see conflict in our lifetime. That's quite possible. Mm-hmm. People didn't believe that 9/11 could happen before 9/11 happened. So to me here, the challenge more with waste and long-term isolation is not about the feasibility, but one thing we've completely left out of this discussion is consent. And looking at what we're talking about here, I just don't see how you can ignore the consent discussion, though, because it's like, hey, stranded fuel. I take it back to the Dutch example. The Dutch example is a great example of a planned long-term storage solution, right? And it's a great example for a smaller problem than we currently have in the United States. The Dutch have a much smaller nuclear fleet and therefore a much smaller amount of nuclear waste to store than the United States. I would love to go to this place. It's a museum. It's fantastic. It's a great place. I applaud what the Dutch have done. We'd need many of these, and we would need several of them built sooner rather than later, because there's fuel sitting in Vermont Yankee and all these other places that no longer operate. Those communities are facing already existing financial burdens. I don't know if you watched any of the testimony around the original precursor to the Civil Nuclear Credit Program, which was in the American Nuclear Infrastructure Act, but they had a city administrator from a city with a closed nuclear power plant in Michigan, with the waste stored on what they consider high value coastal property that they could be selling for tourism value or redeveloping for recreation. And they're like, please God, my city is going to disappear because we don't have the revenue and we can't use this land. Please get us some help to remove this waste. A consolidated interim storage facility somewhere, a repository, a beautiful museum like you showed where they had that. But again, we need multiple of those facilities. And we have two commercial entities in this country trying to site commercial facilities right now, and they can't do it due to state opposition. One of them is received, moved through great processes of the NRC licensing process. I think they might be nearly done, but they can't move forward because of state opposition. And the governor and the state wrote letters and all this stuff and everything. So we need options for moving this waste sooner rather than later for some of these communities, not from a technical standpoint, because it's a public perception nightmare.
So what I was zoomed in on there, that's a Cook nuclear plant. I don't know if that's retired yet, but you mentioned Michigan.
That's still operating.
Yeah, this is terrific. It's way out in the exurbs, but there's a golf course here. I'm sure they would love to extend that golf course as far towards this plant as possible, but if they have to store the used fuel here, that is sort of a policy concern that would not be, dissimilar to what you were talking about.
Right. And I love Cook, great plant, and it should operate for many, many more years. But I also believe eventually at some point in the future, maybe 20 years, maybe 40, maybe 60, I don't know. I believe there's going to be much more economic and better advanced nuclear concepts to replace or build at these sites